Hello, anatomy students. We're back for round two, and we're going to wrap up the rest of the digestive system here. This is going to cover accessory organs that include the liver, then the pancreas. We already talked about a little bit from the first video, but we'll kind of come back to that a little bit. The small intestine and large intestine, and basically the removal of waste from our digestive system. So we'll start with the liver, and the liver is the largest solid organ in your body. It's pretty large. It can be up to 3 pounds. It actually has the ability to regrow if it's damaged. It sits just under the diaphragm on the right side of your body. And the liver is broken into two large lobes, two big halves, and it's held onto the roof of your diaphragm, if you will, by what we call the falciform ligament. So here's a picture. You can see the two lobes or two kind of halves of the liver held together with this really thick ligament right there on the diaphragm. And the liver right here is connected to the gallbladder. The liver is secreting this digestive material called bile. We talked about it a little bit, but we're going to get into that more. And the bile is stored in the gallbladder until it's time for it to be used. Then it squeezes into this duct and goes into the small intestine. And it shares a duct right here with the pancreas. So the pancreas is secreting that pancreatic juice, and they both secrete that into the very first part of the small intestine together. So it's broken up into lobules, smaller sections that are separated into sections for blood flow. The liver is made up of what we call hepatocytes, liver cells, and their job is to secrete this bile, this material, maybe a quart a day. That what it does is it's got a high pH, and it's a really good it's a good breaker downer, a good digester of fats. It's an emulsifier. Emulsification is a really fancy way of talking about breaking down or digesting fats. So the liver, it's got a lot of metabolic functions. Sometimes it's called the chemical factory of the body. All of the blood that has come from absorbing nutrients has to be filtered through the liver, and it also has to secrete these materials, the bile salts, for digestion. It's picking up worn out red blood cells, RBCs, and it's where a lot of vitamins are actually manufactured and minerals are released into our body. The gallbladder is this little accessory organ on the liver that stores the bile so that it can be secreted anytime our body needs it. Now, you may have heard of some people having their gallbladder removed. You can actually live without a gallbladder. You can just secrete the bile straight from your liver. The only thing is you got to watch your diet, because if you eat too much fatty foods and you can't secrete enough bile to break that down, then you will have undigested food moving through your digestive tract, which is a really bad thing for us. So here's another picture of the liver right here with this bile duct secrete, or the right here at the duct attached to the gallbladder, and the bile duct going into the very first part of the small intestine. So we've got the two halves leading to a common bile duct that goes from the gallbladder, and it's also shared by the pancreas. And we talked about the unfortunate aspect of this, the side effect of this, which is where sometimes you can have a gallstone clog this common duct, and then that prevents the pancreatic juices from getting out. The pancreatic juices will back up in the pancreas and really start to cause some damage, and it can be actually life-threatening. Now, all of these meet in the small intestine, and the first part of the small intestine is called the duodenum or duodenum. You can say it either way. This is the first maybe 12 to 14 inches, and this is kind of the mixing station. We've got acidic chyme coming out of the stomach. We've got basic pancreatic juice coming from the pancreas. We've got basic bile coming from the gallbladder or the liver itself. And all this is mixing together. So the acidic solution from the stomach is meeting with the basic or alkaline solutions in the small intestine. And then the intestine secretes its own intestinal juice, which is again another basic or alkaline section. Then the jejunum, the largest or the second portion of the small intestine here, is where we start to do a lot of chemical absorption. And the ileum, the longest part, the last section here, is the final stages of nutrient absorption before we get to the large intestine. I wouldn't expect you to kind of follow this picture along here, but you can just see the complexity in the folding of this. But understand that this long digestive system is kind of a superpower for humans. The longer our digestive system is, the better chance we have to absorb nutrients. So the longer it is, the longer we have, the longer time we have, the more surface area we have. So the longer our digestive system is, the less we have to eat. If we could somehow have a digestive system that was 3 times longer and we could absorb every possible nutrient out of it, we might only have to eat like once or twice a day. This is a breakdown of a microscopic cross section, and you can start to see the covering or the mucosa here. This little tiny lining in these single cells with these little tiny projections called villi. We're going to talk about these. These are stacked on top of these little finger-like projections that stick out of the surface of the small intestine. And what these are all there for is these are all there for absorption. So what we're doing in the small intestine is we've got a lot of different materials that are breaking stuff down. We still have breakdown from what's left in the stomach. And we have pancreatic juices that are working here, bile, and all of this is breaking down in the large intestine all at the same time. The large intestine's job is less digestion, more absorption. That first section of the small intestine, we've kind of got mixing and breakdown. But in the last section of the small intestine, it's really just about absorbing the nutrients. These nutrients have been broken down into the really small pieces. Now that's our job. How do we absorb the nutrients in the small intestine? Well, we need a large surface area. So the internal lining, the walls of the small intestine, are covered in these things called plicae circularis, these circular folds. And I'll show you what this looks like. So this right here is a magnification from a human intestine, a small intestine. And you can see each of these circular folds, these plicae circularis, are here. And those folds increase the surface area so that in between each of those folds, you can imagine all this liquefied food material mixing into every little nook and cranny there so we can absorb as much of those nutrients as possible. Now, on the surface of that mucosa, we've got villi. I'm going to flash back to this picture. Those are the villi that are covering the surface. Now, these are microscopic, but the surface of the plicae circularis. Now, you can't see the villi in this picture because they're microscopic. But even beyond that, on the surface of the villi, we have microvilli. So these little microscopic projections. And what that does is it's threefold. Each of these different layers adds to the surface area of the stomach. The small intestine. The more surface area we have, the more nutrients we can absorb. So this is a picture right here of the mucosa. Those are the villi. And if you look, each of these cells, each of those little dots right there has microvilli on its structure. And then once again, each of these are folded up on the surface of the mucosa right here on the circular fold. So this is a picture of one cell, and then right there you can see the microvilli on the cell. So from microvilli on a cell, the villi on the surface of the circular folds, and then the circular folds. All those come together to increase the surface area to maximize nutrient absorption. Now, all this is moved through with this mucosa, this muscularis right here. You can see the layer of muscle that's helping move food through it's not even food at this point in time, this digestive material through the small intestine. The small intestine is primarily an absorber, right? We get a little bit of material into the stomach, but about 90% of the rest of this is occurring here in the small intestine. And this is taken in through a variety of different ways: diffusion, osmosis for water, facilitated diffusion for large molecules, and even active transport, where we have to spend some energy to absorb some larger molecules across our cell surface. Now, I'm not going to ask you to break these down, but I will give you a heads up that when you get to a college anatomy physiology class, it doesn't just become, hey, there's different types, but you're going to talk about the size of each molecule and as they pass from the digestive system through the mucosa into the bloodstream. Each of those is a different process. Now, what happens is this material is absorbed into our bloodstream and then taken through this hepatic vein and artery to the liver. And this is where the liver filters out any toxins or chemicals or bad stuff that happen to be in your food, that happen to get in your digestive tract that we don't want in our bloodstream. Now, this is what I was talking about before. is that this is where alcohol is also filtered out of your blood. So when you drink alcohol, unfortunately, it's absorbed directly by the stomach and it goes through our body. So it hits our brain, it hits our organs, and then later is filtered out of our body through our liver. So the liver gets all of the bad stuff out of our bites of food before that blood goes into our body, except alcohol, which is directly absorbed by the stomach. So the small intestine also secretes this material called intestinal juice, and it's again slightly alkaline. So everything that's after the stomach is slightly alkaline or basic. Everything in the stomach is acidic, and what that does is that allows them to cancel each other out and become a neutral solution. The small intestine moves food around in two different ways. First, it takes a section or a segment of small intestine and it sloshes this food back and forth to make sure that every circular fold, every villi, every microvilli has a chance to absorb that food as much as possible. Just like when you take a drink out of the refrigerator and you shake it up first to make sure it's all well shaken before you drink it. The same is true here. It shakes this material back and forth, and that's called segmentation. And then once that material is shaken back and forth in that little segment of small intestine, it moves along through peristalsis, which we already talked about, lengthwise to another section or segment where it sloshes back and forth, and then moves along and sloshes back and forth, and then along and back and forth again and again to make sure that we absorb as much of that nutrient material as possible. When we get to the large intestine, we are talking about waste material. So this is material that essentially all the nutrients have been taken out of here. The only thing we're really pulling out of the large intestine is water. Now there might be some remnant vitamins that are also mixed in through the water, dissolved in that solution, but essentially all we're doing is dehydrating the fecal material for the release and defecation. So looking at the large intestine here, we've got these different segments. Right there is the last part of the small intestine until it goes into the ileocecal sphincter, this little valve that prevents material from the large intestine to fall back into the small intestine. We have the ascending colon, the transverse colon, the descending colon, and the sigmoid. And it's called sigmoid because it's kind of an S shape. And then we get to the rectum and the anus, the end of this digestive system. Now, here is also our appendix, which is worth talking about a second. That's a vestigial organ, if you remember that from biology. And the idea is that this probably used to be an accessory organ to digestion. It probably used to be that this was an organ that stored some digestive enzymes that maybe digesting cellulose, that material in plants that we don't digest, that other animals do. But now it doesn't serve a function other than as a storage device for bacteria. Now, unfortunately, bacteria can grow in this and grow and grow and grow, and this thing will swell up just like a water balloon. And if your body can't keep up with keeping that bacteria level from expanding, it will burst. And that's what we call appendicitis. And hopefully, somebody who has appendix pain will note that before it actually bursts because it's like a little miniature bacteria hand grenade going off inside of your body. That's not a good thing. That requires a surgical repair and a lot of antibiotics to prevent that from becoming a serious infection. The large intestine basically completes our absorption through removal of water and removal of water, and then understanding that there are some vitamins that are also absorbed in that water. And this is where we actually form the feces, the fecal remains that we're going to expel from the body. The walls or sides here don't have any villi. There's no microvilli. There's no villi. They're smooth and they're covered in mucus because at this point in time, we just want this material to go through, right? This is just a temporary holding facility for waste material until it's time for mass peristalsis. It's time for us to release this material out of our body. Now, inside of our large intestine, we've got haustra, these little segments. And I'm going to go back to this picture right here to show you that little bulbous segment right there and right there and right there, those are the haustras. See, there's a picture right there. There's one. And what these are is these work like big paddle tires on a four-wheel drive vehicle. All right. And the haustra right here are folds that pinch and bind this digested fecal remains and move it along. The inside doesn't have any traction. The inside is smooth So we need something to bind and push this material forward, and that's the hostra. Taenia coli are these longitudinal bands of muscle that kind of keep the peristalsis moving. And then inside, there's these small fat-filled appendages called epiploidic appendages until we get to the anus. And then there are parallel ridges within the anal canal that help reduce friction and move this material out of our body when it's time to release it. So right here, you can see there's the surface of the large intestine, no villi, no microvilli, no plicae circularis, just smooth and flat, covered in mucus because we want to move this material out of the large intestine. That's it. We're just interested in using this muscularis to get these fecal remains out of here. Postural churning is what we call this material of individual segments moving this fecal material along through what we call peristalsis. And then mass peristalsis is the actual release or defecation of this material, the pressure and removal of this at the last stage of digestion. So at the end here, the last stage of this, basically we have nothing left but the remains of food, bacteria that was attached to the food and breaking this down, any remains of proteins or amino acids we didn't absorb, and then any remaining water or maybe salt products that are left here. That's the end of our fecal remains. This takes maybe 3 to 10 hours from a meal. It depends on activity level and age and and health in general. Uh, but that's it. And defecation is the actual emptying of the anus itself. Diarrhea is unfortunately when we give too much liquid, we have undigested food that passes through our body, and that makes a lot of water come out at the same time as the fecal remains. And the opposite of that is constipation. And constipation is when there's actually maybe an over dehydration of the fecal remains. It becomes dry and hard and very difficult to pass out of the rectum for someone. Just going to talk about a few issues with the digestive system that can arise here. These are not on the quiz. I'll just tell you right now that I think there's only one that's on here. We already talked about it, which is diabetes, but just a couple of things. We talked about cirrhosis of the liver. We saw this before in the human dissection video because the gentleman who donated his body to that project died of cirrhosis of the liver. And this is essentially an issue when the liver cells start to die or they become to the point where they cannot heal themselves. The liver can actually repair after it's damaged, but when they can't maintain their own metabolism, then you'll start to have a lot of urea build up in your bloodstream rather than be filtered out, and then that affects brain function, and that can be very serious. And that's a very common side effect of alcoholism. Some symptoms that come along with that is jaundice. I don't know if you've heard of jaundice before, but jaundice is when bile salts like bilirubin are released into the body and it causes a yellowing of the skin and the eyes. And normally that would not happen. The liver would remove that. But when someone has a yellowing of the skin or the eyes or the fingernails, we call that jaundice. Appendicitis, we just talked about a little bit. That's when you can have a bacteria build up in that appendix and it can possibly burst. Gallstones, we talked about as well. This is when bile salts will actually dehydrate inside of the gallbladder and then block that passageway, and that can be really serious and really painful. Tumors are not uncommon, unfortunately, because we have a lot of cellular turnover in this mucosa, in this lining. There's a lot of places where the cell, just like our outer skin, is constantly turned over, and obviously skin cancer is probably something you've heard of. Well, on the inside of our body, we've got a lot of chemicals that are moving through our body as well as the digestive material. So there's a lot of turnover of that skin, that internal mucosa as well, which obviously lends itself that every time we do cellular reproduction, there's a chance in that mitosis for an error, and we could have a cancerous cell. Hepatitis is an infection of the liver, and there are multiple types. I've got A, B, and non-AB because it goes all the way up to, I'm not sure if it's even to F by now. But this infection of the liver can come from a viral infection, or it can come from damage from drugs or alcohol or steroids that you might be taking. It can also be a genetic aspect that leads to a dysfunction of the liver. Obesity. We got to talk about this in the digestive system because this is a serious issue in the United States. With a fast food restaurant on every other corner, it's really difficult to always make healthy choices when we're eating. You guys know that, obviously I have a little soapbox about this because I spent a good time of my life being a very large person And now I'm working at being a little more human size and understanding that, our bodies were meant for activity. We were meant to eat balanced diets. We were meant to move and exercise. And that's absolutely within each one of us, regardless of whatever our genetic predisposition is. We can all make healthy choices there. Once again, kind of getting back to, I know I've talked about the Biggest Loser TV show, and regardless of the hip the regardless of the issues with that show and some of the unfortunate, things that have occurred, one of the things that I always find inspiring is watching the health ailments of these people losing weight disappear over time. Their high blood pressure, hypertension, all these things, diabetes, disappear once they start exercising, moving their body in a healthy way, and making healthy choices with their eating. Ulcers, the last thing we'll talk about here. Peptic ulcers can take place most commonly in the stomach. Sometimes these are as simple as an overproduction of acid, but they can also be the result of a bacterial infection. That was something that wasn't even really discovered until the 1990s. They thought there's no way a bacteria could survive in the stomach because of the stomach acid, but it shouldn't surprise us, right? We have bacteria that have found a way to live in thermal vents in the bottom of the ocean and everywhere on this planet, so why couldn't they live in our stomach? And it turns out that they do. So sometimes these bacterial infections can take root in our stomach and prevent that mucosa from protecting our skin. And when it doesn't protect our skin, then the acid burns our skin and we end up with a peptic ulcer. And hopefully these don't become so serious that they actually create a hiatus from your stomach into your internal abdomen. But that does happen, and sometimes that can be something you have to actually correct with surgery. And that is our final slide. That's our digestive system. I know that's a lot of stuff, but looking back at the quiz to prepare you for that, okay, take a look at the pancreas. The pancreas is secreting pancreatic juices primarily to break down proteins, but also help with some other materials. The liver and gallbladder are producing bile to primarily break down fats, and then the intestine secretes intestinal juice that kind of breaks down all those fats, proteins, and carbohydrates. All three of those are alkaline or basic solutions, and that counteracts the acidic stomach acid that's coming out and mixing in with the small intestine. The large intestine doesn't have any absorbative properties other than to really remove water at the end. We're just talking about removing waste. All right, you guys, good luck on quiz number 2. I wish you guys the best. If you have any questions, shoot me an email. Thank you, guys.